I'm not recording now. Am I recording? Do you see the right screen? Okay. This is what we ended last time. Download pets. Download pets. Use the same project that you have. Make sure that you convert the file into the format that we need for R. Make sure that you set up a new script. The new script should always have the beginning code and should always have the closing code. If you don't remember, and do you remember exactly what to do? Oh, hell no, you shouldn't. This is not a class about memorization. There's a little bit of memorization that is key. This is not one of them. If you don't remember what the code is, where can you go find it? From the script in the WASP script. So open up the WASP script as well. Copy and paste out what you need, and then put it into the new script, which is going to be pets. As you guys are doing that, tell you a little bit about the study. I think I mentioned it before, but it's been now 2.5 weeks. This is a study a student did looking at how pet ownership is associated with people's conservation habits. There's a study that was done with something called mTurk, which is a, I don't even know what to describe it as. It's a system Amazon runs that allows you to put in tasks that people do for a small reward, small payment. You can ask them to transcribe some Spanish, which I've had people do, transcribe Portuguese, which I've had people do. I am monolingual, it's terrible, but that's me. So I put this out there, someone volunteers to do it. We get the transcription, they get an award for this one. They did a survey. Survey took about 15 minutes. We paid them 75 cents per submission. In about 48 hours, we had over 3,000 responses, representative of the entire United States, all 50 states and territories. Urban, non-urban, suburban, rural, all widely covered, giving us a really robust sample of individuals that took this study for us. As you create the project and you create the scripts, take a look at the data. When you look at data, and these data are clean, there's nothing wrong with them, they are perfectly structured, you don't have to modify them, but take a look at the data, determine what are these individual values. You may not have enough information. This is where you think of questions to ask about it. What do they describe? If you're really good and you're able to actually get it installed, not just sort of set up the script, but get it installed and get it running in R, do T-apply on them. Okay. Make sure I'm working. Can you hear me online? If you are online, you are equally game to answer questions, just like everybody else. So make sure at this point you have your microphone off or you put it in chat and I'll translate out for you. All right. So do I see, let me get this. Okay, Ashley. We're starting here. This is a project I was working on earlier today. Something about the Amazon, has nothing to do with class. I need to get the project we need for class. So what do I do? Oh, that's clever. I can do that. Okay, so we're going to go to Finder. And I'm going to go over here. I'm going to open up that. And you wouldn't know where this is. So I'll walk through here. I go into teaching. I go into biostats. I'll do this by year. And then I have my projects for the semester. And I would open up right there. But I'm going to do this a little bit differently, so that you guys see another way to go about this, maybe. So you can go up to RStudio, you can go to File, you can do one of two things. You can open up Project or open up Project as a new session. Opening up a project will turn off the previous project. Opening up a project as a new session will allow you to have two running at the same time, but sometimes packages can interfere with each other. That is a choice of yours. For us right now, I'm going to open up if it's a project. I'm not going to save the workspace. And now I do the same thing. I go to Finder and I go down to where we're located. I like to do this through RStudio, but honestly, it's just how you find the answer. Here we have number 4. That's for our 4th unit. Underscore descriptive statistics variation. That's my project name. I open up that. And we have the project, which is good. I can go back here and see if I have my data already set. I have my data in there, which is good. Let's go back here. Let's open up code. We have pet. Okay. So, Dominique, what is the first few lines of codes always in a script for us? Loading packages. Now, if you don't have this here, right, and I'm going to get rid of it. So let's do everything. Let's select all, delete it. I lost it. I've saved it because I get really panicky anytime I see the red. So now I have nothing. So now I need your help because I need it back. Where can I go get it? Okay, I click the file. I open up a recent file. I open up pets. Nope, I screwed myself. It's gone. Great. Do we have one available? Let's do that. So I open up WASP. Notice both sets of scripts pop up. That's fine. Both sets of scripts get there. So I can copy out the ones that we want for right now. Copy that. I paste it in. All right, we're good. Jamie. Let's see, Jamie. Yeah, what do we do next? Before I do anything, I always want to do the same thing. I want to set up the code initially with the beginning and the end. And then we'll fill in the meat. Let's do that. I love that. So you said, don't mess around with just part of it. Get everything, come over, paste everything. Is that what it said? Okay. Do we like this top part? I like that. Do we like this bottom part? I like that. What about the stuff in the middle? Needs to be different. Do we have to delete everything off the top for our head? Good. Why? Why? And that's one of the things. Be efficient. Do we have to delete everything? No. We're going to have to read a CSV file. So we keep that first line. We're going to have to change some things. We're going to want to do a summary. So that's no big deal. We can leave that. Then we'll do some modifications later. So, Gabrielle, help me with line 7. Line 7. I need to fix line 7. See, this isn't going to work. It's not going to give me what I want. I don't want wasp behavior. I want pets. Y'all know Control Z and Command Z? Everyone knows Control Z and Command Z? It's your best friend in R. Don't delete stuff all the time. Control Z, Command Z just undoes it. So what am I doing now? All of it? Okay. Great. What do I do now? Love it? Love it. So now this is one of these moments where when you talk to old school R users, they will talk about the days where they had to walk uphill to school both ways through the snow, because my God, this used to be a pain in the butt. And like you could tell a person who used old R when they sort of see this and like this sense of relief and then annoyance because you don't have to suffer like they did. Goes over their face at the exact same time. How you should respond was a little bit of schadenfreude and just enjoy their misery as it's much easier for you. So we do this, we run it. Oh, we got an error. That's terrible. So, Madison, I just ran line 7 and got an error. Run again, see, error. So I run again. That's an error. That's an error. That's an error. Everything's an error. I just, it was too much for me. Let's file a CSV file. We can go check. We can go over data, pets, yep, pet CSV. We're cool. We're cool. Should I run it again? Yep, coming up as an error. Should I do it again? Could be pets underscore, but actually I can look over here under my file names and see that is pets.csv. Oh, it can be. It can be. Actually, either one of those will work. And that did work. Ooh. We're going to be using read underscore. I'll explain why in a half a second. Yeah, read.csv will work. Sure, but we'll keep doing it. Okay, so we'll keep going. So let's do dot. So we have a solution. This works. When we got our summary, that's cool. Life is good. Life is good. Should we keep going? Yep. Oh, no. Yep. We got errors. And it's the same error that we started with. Now load your packages. Read underscore CSV is tidyverse. Read.csv is the base program for R. It honestly doesn't matter. But later we are going to be using tidyverse because of piping. And we're going to be using tidyverse because of dplyr. We're going to be using tidyverse because of ggplot2. We're going to use tidyverse for a whole variety of things that all come together. So right now it's a good habit to just start using tidyverse in sort of simple and easy ways. The first thing you always want to do is load your packages. You may have a case where you don't have any packages. You gave me the Drake equation, which by the way was cool. And I was kind of thinking I was going to be sunsetting that assignment. And then you guys came up with new ways of thinking about the assumptions that made me happy. So I'm going to keep the assignment for another round until I get bored. But there was one person who was talking about lifespan of the universe and taking off the percentage of what they consider an absolute based on whether the lifespan of the universe would have dictated the presence of galaxies that could basically produce planets. I was awesome with it. There were a few flaws, no big deal, but I was awesome with it. So as long as it keeps being interesting, we keep it. Next year they get the Drake equation still. So always start with the packages. Always start with the packages. Then this line doesn't obviously matter. We can do either one. We can do summary, that's working. Now we have an error. For that, Diana? Okay. So we have to do some changes. We have to do pet ownership is pet ownership. Are there any other factors we need to deal with? Education. So we can add another line by just putting a comma after the first parenthesis. Education as that factor, education. Now we can run that. We could do attach. We can do summary. And we're good. Notice we have pet ownership. In this survey, it's self-selected participants. Not surprising, a survey about pets. The vast majority of participants were pet owners. Percentage of vegetarian diet, animal view, education, wide variety. This is also biased towards a college age population. So while we got good representation in terms of urban, suburban, and rural, good representation in terms of states, definitely this study was biased towards more educated individuals, and it was biased towards individuals who have pets. Okay. So I'm going to put this up for a second. What I want you to do is I want you to look at those data, describe what the values are, what are the variables. I'll leave the script back up so anyone who wants to sort of use the script to get caught up can still get caught up. And then I'm going to delete these parts because this is not germane to us right now. So we have that. Let me give you guys about 3-4 minutes to think about those 4 variables, what they mean, what they're defined as, and then we'll continue. Should I be happy? Well, that's good, but I'm asking about me. Should I be happy? Should I be happy at this point? No. Well, I don't want to clean up yet. I still got work I want to do. But I should not be happy at this point. Why should I be concerned at this point? Anyone else? Save. Really get in the practice of saving. It's a small thing. You see your file name up there as red, means that you are unsaved. If you're not sure where you were in the process before you do anything, save. If it's like 2 seconds, you know exactly where you are. Don't worry about it. If you're actively working, don't worry about it. But when you take a break and you come back and you see it's not saved, save it. You don't want to lose your stuff. Okay, so I asked you guys to use tapply. I'm going to come back to you first. Here are variables: pet ownership, present vegetarian diet, animal view, education. I want to look at something with tapply. And if you remember, tapply is kind of like a mini little pivot table. It allows you to look at descriptive statistics for different factors of a variable. So give me an example code. I'm going to start you off, tapply. We're going to do a parenthesis. What variable do you want to look at first? What were you most excited about? Pet ownership, percent vegetarian diet, animal view, or education? Okay, so tell me what to do. Okay, nice thing is it kind of automatically pops up. What do I do now? Comma, love it. What do I do now? Great, now? Ooh, ooh, that was ugly. Does that make you happy? No, what are we getting here? You guys understand what we're getting here? It's kind of cool. I didn't actually know this would occur, but it makes sense. What is our output? For the first 1,000 data points, for each individual participant, it gives us a 1 or 2 based on whether they have a pet or not. And then it deleted or just omitted 1,899 data points. So is that what we wanted with our tapply? Give us information, but not the information we wanted. What is the last piece that we want to put in? Fabio, you're working with Fabio and Sean. You guys are working together? Okay. So Connor, if I go back here to my line 18. What's that? We want to apply a function. Okay, so what do I do? I'm outside the parenthesis right now. What function do I tend to use a lot of to begin with? Gives me good, simple descriptive statistics. We could. Descriptive statistics. Yeah. Summary. It's a good one. We run that, we get an output. This looks more like what we would expect. For individuals that do not have pets, their mean vegetarian diet was around 68%. For individuals that did have pets, their mean vegetarian diet was around 67%. Is there any dramatic difference between these two? No. Do we know anything definitively at this point? No, but looking pretty good. So that works. That works. So I like that. Let me try something else. What about if we did this? We take this, and what I'm really kind of interested in is this animal view thing. An animal view is weird. So we're gonna get some weirdness about animal view. If you notice what R did when I typed it out, what do you see happen? I'll do this again. I'll delete it. Animal view. I'll pop it. Did it just type in the 2 words animal view, or did it add stuff? Add stuff. R doesn't like spaces. R does not like spaces. So one solution in Excel, get rid of all spaces. Another solution, if you are in R, you could put these forward quotes. These forward quotes are found in your keyboard right under the tilde sign. The tilde sign we know, which is above the tab, and we need that for by, and we'll use that all throughout the semester. That same key will also give you these little forward quotes. If you don't put them in there and you write out animal view and then hit tab to automatically populate it, R will just add it for you. Right, right. So these are quotes to say this is a word, an object. In this way, it's a pathway. Go to the folder data and then go find the file pet CSV. So it's not looking at it as a function or to do something in R, it's knowing that just go find it. Here, this is part of an overall function. So for percent vegetarian diet, let's figure out the summary data relative to animal. What is that? Animal view. So should we try it? One more time? Oh, everything's case sensitive. Yeah, R is entire, like all coding. Coding is case sensitive. Oh, so Madison is not seeing any variable pop up. So I go back here, I type in pet ownership. Anyone have a guess why Madison is not seeing the variable names pop up? Amanda? Bingo. Most likely it's this line right here, line 15. Line 15 is a very silly little piece of code that will make your life much, much easier. Attach places the variable names into R. So you can just use the variable name. You don't need it, but then you're gonna have to use the data frame, $, the variable name for R to see it. Two reasons. One, it's data frame, and second, so we never have to rename anything. We use the exact same DF all over the place, and we just don't have to try to bother with it, which allows you to copy and paste code much more quickly from one project to another, to make use of it much more quickly from one project to another. Okay, so I'm gonna run line 19. Oh my, oh my, oh my, oh my, my, oh my. Oh Lord. What's going on? Does this make any sense to anyone? Does this look right? Is anyone excited to see how long this goes? Good, me neither. Let's get rid of it. Line 19 was a complete bust. Terrible. Can you tell me what was going on? Connor? I was giving you summary statistics of percent vegetarian diet for every unique number in animal view. That's 3,000 unique numbers. And therefore, it was just telling you the value. T-apply needs to have continuous data and categorical data. So it's continuous by categorical. Animal view is not categorical. What is the other type of categorical data, otherwise known as factor? What could we do? Education. We run that. We get this. That looks pretty good. So if you're still getting down code, the code is right there in blue. Graduate students, mean around 69. High school, mean around 65. Some college, 66. Some high school, 63. Undergraduates, 69. Honestly, very similar to each other, though there might be a slight increase in the amount of non-meat in as you get more education. Might be. Do we know yet? Nope. One of the things I like to do when I'm working with data is just look at overall patterns before really getting into answering questions. All right, so we have 4 variables: pet ownership, percent vegetarian diet, animal view, and education. Each of these are a different type of data. Each of these get analyzed in different ways, and you need to understand the structure of the data to make use of them. Let me start with the first thing. What is pet ownership describing? Describing whether they have a pet or not. In this case, it's binary. It's yes or no. Do they have a pet? Yes. Do they not have a pet? No. Very simple, very straightforward. What is percent vegetarian diet? How much of their diet is non-meat? I loved how we did this. We gave them a sliding bar that went from 0 to 100%. We gave them different categories and types of foods that they could be eating. They slid the bar. Did their sum is supposed to add up to 100%, but did it ever? No. We could slide the bar wherever they wanted to on the scale. But what then we did is standardize everything to 100%. So we had an actual representation of what they were describing as their overall diet. Is there a minimal value in percent vegetarian diet? Absolutely. What's the minimum value? 100%. That is a hypercarnivorous individual. Is there a maximum value? Is there a maximum? 100. Straight vegan, I think you would qualify as a maximum, where there's no non-animal products being consumed. So in our first case, pet ownership, binary, yes, no. In our second case, percent vegetarian diet, we have a minimum value, in this case 100, 0%, and we have a maximum value, in this case 100%. Can you have a 110% vegetarian diet? No. Can you ever give 200% effort? No. You can give 200% more effort, because then you have a qualifying term to begin with. Maybe you only gave 5% effort. And now you can give 200% effort, which means you're going to give 10% effort. That's possible, but you cannot give 200% effort. You only give 100% effort. And I would discourage that because it means you're not doing other things. I like breathing. I'm going to continue doing that. We have animal view. Did we talk about that? Do you guys remember talking about that? It's this weird number. Yep. It describes whether a person is anthropomorphic or a human exceptionalist. If it's a negative number, that individual tends to be more anthropomorphic. They think humans and animals are similar. If it's a positive number, that individual tends to be more human exceptionalist. It says that humans and animals are fundamentally different. It has no unit, none whatsoever. It is forcing the data into a normal distribution where a mean of, or a number of 0 represents the mean. It's something that we can do when we do things like factor analysis, principal component analysis, and it has a lot of value, a lot of utility, because it can allow you to describe something that you cannot measure directly. You can't measure and quantify a person's bias, but you can use indicators. And those indicators give you a measurable term of preference. And then the last one we had is education. Education is also a category, but is it binary? Educated, not educated? Does it have structure? What's a structure? It's discrete, it's categorical. So you can't be both some high school and graduate. You can't do both at the same time. What else about it? Is there a numeric underlying value to it? Yes, there is. Who has the most education? Graduate. Who has the least education? some high school, and there's a quantified structure that goes into it. That is a different type of categorical data. It can be 2 groups, it can be 3 groups, it can be 20 groups, it doesn't matter how many, but it can be multiple different groups. So the first type is our ratio data. This is sort of exhibited by the % vegetarian diet. This is continuous data with a fixed limit. The easiest example to think of is percentage 0 to 100, where both ends are fixed, but still ratio data, even if the upper limit is not fixed. And there are many types of ratio data where the upper limit is not fixed. You go above 100%. You can in terms of effort, but other things you can. In all cases, though, you cannot go below 0%. There's no less than none. That is the limit. These are continuous in the sense of they are not in separate bins. 1% is different than 1.1%. 1.2% is larger than either 1 or 1.1%, and so on all the way through the cycle. And you can divide it out as finely as you want. You don't have to, but you absolutely can. Interval data is continuous data without fixed extremes. It's a range. There's no absolute fundamental limit. You may not go above a certain end, certain size, a certain measurement. You may not go below a certain end, a certain size, a certain measurement. But there's no theoretical limit to it. So if these principal component data describe essentially standard deviations, going above 3 standard deviations is exceptionally rare. That's around 99.6% of the population is within 3 standard deviations, but you can see things higher than that, theoretically. Well, it can be. It can be. What it can't be is fixed. So it can't be fixed in the sense that you can't go lower than -1 in terms of the number. Biologically, you may not be able to measure lower than that, but in terms of the structure of the data, there's no limit to it. The percent? Well, no, I'm not going to say that. So we talked about that group. Oh, and in this case, 0 means something very different than what 0 means in terms of ratio data. 0 in ratio data means that there is no vegetarian diet. 0 in this case does not mean that at all. In fact, in this case, 0 means the average because of how this particular data is structured. Ordinal data, these are categories that are expressed as rank, where rank has ascending value. So in this case, some education, some high school is a higher rank than some high school. Some college is a higher rank than high school. College is a higher rank than some college. You have more education with each category in the rank. And then graduate, more than college. How are your grades defined? Categories. What type of category? Ordinal. A is larger than B, which is larger than C, which is larger than D, which is larger than F. They are ranking, a category ranking of your overall score. And then last, in terms of these data, are nominal. Nominal are categorical, but they lack rank. Pet ownership, yes or no? So I'm asking how many pets? A lot, little, none, just yes or no. It says population, male or female, one or the other. Present, absent, in person, online, Each one of these are a good example of nominal data. One of the things with nominal data, if you're trying to remember it, just remember the word nominal means name. All you're doing is really using data that's defined as a name. Questions with that? You only need 3 minutes, 4 minutes, take a break. Get up, go.
Because we have it in Excel.
Shabby panic, Fabiola, or anyone online. Lauren, Chandler. You have to save. Thank you very much, Lauren. Oh, on this note, Dominique came up with a very clever idea that you may want to use, especially if you're anywhere outside the first 2 rows. She just jumps on the Zoom. So on her desktop there, she could see the Zoom, and therefore it's a lot easier to see. No squinting because the characters are right in front of her. I thought it was really smart. So if it works for you too, do it. If it doesn't, don't worry about it, but it was clever. So we do this. I have to rerun everything. I dropped it. I hit it. We do this. We do the, wait, okay, so red means bad, right? I got that. Looks like it happened when I ran line 15. Now I got it twice. Now I have it 3 times. And guess what's about to happen? Yep, I got it 4 times. Should I be concerned? Why not? Just doing this in this case, we're doing it before. Red is important information. In this case, it's telling you that whatever was being utilized before is now not. It's masking it. It's resampling. This will only be important to you if you are running multiple sets of scripts in the same project at the same time using things like attach, because it will turn off the ones that you may be running another script. That's the only time it's important. If you start to do that, then reach out and I'll give you a different tactic that would be better for you. But for us right now, it means nothing. Don't worry about it. It can be scary seeing all that red, but it means nothing. Okay, so we'll get rid of that. We'll bring back over here. And this is my question for you. You guys have 3 minutes. Describe a mean without using any mathematical terms. Define it. Describe it. And then what assumptions are being made when we calculate a mean? Make sense? Okay.
I don't think so. A set of yeah.
So Jeffrey.
So the closest we got was we said it's a number that's representative of the data set.
Number of representatives. There's a lot of numbers represented in the data set, like counts represented in the data set, standard deviations represented in the data set, variations represented in the data set, range, max, min, interquartiles, percentiles. And there's a number represented in the data set. I like that start. I like that start. But I'm going to ask for a little more. So, Lauren. I have my little video camera. They're not showing me their video camera, so all I see is sort of black void. But yeah. Nothing yet, waiting. She won't talk to me in my ear. Okay. We have a computer struggling. That's on Lauren though, so fair enough. Lauren, I'm going to come back to you with a question about assumption. All right. Emmanuel, you're next up, but I'll come back to you as well. That seems a little unfair. Haley. And that's a synonym. So I could just ask you now, well, describe average in a non-mathematical term. I get where you're going. What describe that to me though? I can see something in there. What individuals would the mean describe? It describes everyone. So we're all average. Love these questions. There's something we all know, and yet somehow we can't express. Julie? Student scale. What aspect of the scale? Which point? We assume the mean? You can. Not. There's a lot of ways to describe it. It is one of our measures of central tendency. And that is a way of describing it in sort of a non-mathematical term. It is a center. It's one of our ways of describing the center of a population. There are three ways in which we typically describe the center of a population. One is a mean. Means have very specific assumptions, which is why I was asking this question, because it's one that we use most often. We always like to describe things like average and mean, and one which we rarely consider the assumptions that go into it to decide whether it's appropriate or not. Frequently, you don't care about the mean, and yet we describe it. Frequently, the mean is really inappropriate, and yet we describe it. It has a very specific meaning. That was not a pun, that's for the stress, but those are different things. But it's a most common statistical descriptor. It is one of our central tendencies. And we have three: mean, median, mode. Those are our three central tendencies, in that they all describe an aspect of the center within a population, an aspect of the center within a sample. The mean is defined by its assumptions. The median, that's the middle number. We'll go through that in a bit. The mode, that's the plurality the most common representative. We'll go through that in a bit. Many times we really do care most about the mode, where is the plurality. If I give you all 5 choices of how to deal with a semester, we're not going to have a single choice that emerges as an automatic consensus, especially if I made it anonymous, and especially if I wasn't drilling you with my eyes and telling you my opinion beforehand, but actually give you an honest choice, which I did not. It could be all over the place, and we wouldn't be doing the most, we would be doing the plurality, the most common answer. Make sense? The mean, though, has a lot of baggage. So what are the assumptions of the mean? Now, this is where I get to start with Lauren, and then I get to go back to Emmanuel. Lauren? Like, we have some people texting in there, Lauren. So I'll come back to Lauren in a bit. Emmanuel, what's an assumption of the mean? Go ahead. Oh, you may. You can have outliers. You can. If you have a large enough data set, you will, depending on how you define them. Yep, Jeffrey. Assumes a normal distribution. So one of the things about a mean is if the mean is being used accurately, when you define the mean, you are also defining the median and the mode. If a mean is being represented appropriately and being described in the right situation, you are also stating the median and the mode. Because it is a normal distribution, the mean and the middle number will be the same. And therefore the mean and the median are the same. Since it is the middle number, and since it is a bell curve, it will also be the plurality. So the mean and the mode will be the same. Because mean assumes a normal distribution, which means that in a small sample, you would not expect outliers. That's true. In a large enough sample, you will get outliers just because it's large, and you'll eventually see them. But it assumes that normal distribution. That brings up a question. How common are normal distributions in the real world? How common are normal distributions in biology? Biology is not normal. It's interesting. If it was normal, I would not be majoring in biology. If it was normal, I would not be professor of biology. It would be boring. Biology is not normal. And therefore, mean is more often not an appropriate tool in biology. Median tends to be much more appropriate, sometimes mode, because a mean is based on an assumption of a normal distribution. And we will talk about that later in greater detail. But our 3 central tendencies are mean, median, and mode. To get these in R, it's really simple. You just do median of, you apply if you want. We have the continuous variable, comma, the categorical variable, comma, mean. Very nice and easy. Median. Median is the middle value. Half the population is above and half the population is below that value. That's your median. Beginning of the semester, we talked about an average salary. In Southwest Florida, the average salary is huge. By US standards, it's enormous. By world standards, it's insane how large it is. And at the beginning of the semester, we asked, how rich do you feel when you learn that the average salary is so high? Not so much. We used to have all these people that lived along the coast. That stopped about 3 weeks ago. That may be too early for the jokes, but they're there anyways. Those individuals had massive effects on the mean, greatly inflating it. The median is much more appropriate there because it describes the center value. Half the population is above, half the population is below. Mode describes also a center value, but describes a plurality, the most common representative. Strangely, that is so obnoxious and difficult to calculate in R. Don't. Use a pivot table if you need mode. It is truly obnoxious to get it out of R. So, questions with those? Now, why do we care about central tendencies? I pulled these maybe 3 weeks ago. This shows annual precipitation in Southwest Florida in terms of 5 and 10-year periods. Boxes and the individual lines and points show the amount of precipitation in that year, really about the past 120 years. This dark black line describes the average. And what do you notice? The mean. What do you notice? I was actually surprised by this. Is the mean a fairly good representation of the precipitation? I'd actually say pretty good. I would say there's variation, therefore you don't want to stop with the mean. We'll get into that. There's a lot of variation, it bumps up and down. We have some years of really massive drought. And then we have some years of exceptional amount of rain. But do we see any sort of change in precipitation over time? Do we see a nonlinear relationship in terms of precipitation over time? Do we see after a period of time, maybe like after World War II, 1945, that all of a sudden precipitation starts to go down? Do we see an increase maybe in the 1970s when we had our first gas crisis where precipitation started to go up? Do we see any sort of overall change in terms of precipitation in Southwest Florida? Or is the mean kind of doing a good job describing all this variation? We have a lot of variation from one year to another in terms of rain, but is the mean doing a good job describing precipitation? I think pretty good. I think pretty good. Oh, happily. Now, what about temperature? Same basic data. Early 1900s, going all the way across. This is the mean. And this is the mean. Let me make sure I get that number exactly. Not in my glasses, I can't see. From 1900 through year 2000. That makes it a little bit easier, right? That's a lot better. That's the mean temperature annual. We have like cold year, we have some warm years, and then we go and we continue on up all the way through. Doing a good job describing the annual temperature in Southwest Florida. Do we agree it did a pretty good job describing precipitation? A lot of variation, but that line seems pretty representative today as it was 120 years ago. What's going on? It looks like somewhere around through here, we're starting to see an increase. Is what it looks like. These are being associated with climate change, we assume, but we're starting to see that effect today. One of the things, I don't know if you guys ever watched local news. I find it kind of comical watching the weather person get on and say, today it's going to be a high of 96 degrees. Relative to the average, that's about 4 to 5 degrees hotter. They say the same thing every day, not noting the fact that they're saying it's a little bit hotter than average every single day. Means have good descriptors. This is a very valuable descriptor. In one case, I was surprised. I actually expected to see some changes in precipitation. None I could see. But in this case, we do have what could be, especially if this trend continues, change in evidence of temperature. roughly around 1940. We got this 3-year cold year period. It looks like it. Oh, and Hiroshima was in 1945. So it would have been at this year right here. Yep. So there could have been volcanoes. I actually don't know. It could have been volcanoes. It could have been just random. And it's one of the reasons we see so much variation. I don't know. It's a good observation. So the central tendency is, is a central tendency valuable data? 100%, totally valuable. Is it the only important information? No, now is one of the things that you guys were responding to here. The central tendency is valuable. We have pretty consistent precipitation over time. But one of the things you will notice right off the bat is we have also a tremendous amount of variation. You don't just describe one property, you need both properties. So, yep, let's do it. Yeah, let's do it. All right. What I want you guys to do is we're going to model out some theoretical normal distributions, and then we're going to compare these to some randomized normal distributions. So let's play with that. This is just up there, so you guys get started on it. I would keep this in the same script as your pets, though it's unrelated to your pet. So I personally would add an index in that script that tells me I'm doing something else. In doing this, I also want you to translate these lines of code into typical.
Like a note.
Yeah. Like mathematical equations, if you are able to translate the information out, it ends up being a lot clearer for you. That is an L, lowercase l. Misty, you're here, right? Catherine? Julie, you're here. Chandler is here. Amanda's here. Bill, you're here.
And Victoria and Ashley.
Just didn't have enough space over the plot area to show. Okay, so I'm going to copy all these codes right here because it includes notes for me. I'm going to go over to R. So people ask about opening up a new script. You can absolutely open up a new script because it says the section on normal distributions, and we're modeling out normal distributions. But I'm just going to keep it in the same space. Oh, that didn't work. Try again. Copy. Go back here. All right, I got my notes. I have some problems. Notice I have an issue in line 25, and I have an issue in line 29. How can I look at the RStudio and recognize that I have an issue that I probably need to attend to? What should I notice in line 25 that's telling me I probably have an issue, Gil? The little X. The little X is telling me I got some problem with this code. One of the things that I personally like to do with codes is I like to separate them out after each comma as a separate line. That helps me keep track of things. It also helps me identify where that error might be. So I'm going to go back so you can see that again. Notice I have an error in line 25. That's what Gil just identified for us right here. I hit this. I hit this. After each comma, I separate it out to its own line. I have that error right there. And now notice when I put the cursor over the error, it's giving me some information. What's it telling me the problem is? This is the straight quotes versus curly quotes. Curly quotes have extra code in it. R can't read it. So R cannot read something I type directly into a PowerPoint. It has to see it as an ASCII. Now we should be good. Notice that the error is gone. I have a second thing. It's not exactly an error, but I got another issue. What should I be doing here in line 31? One line or an enter. So it's two separate things, whatever we want, right? So we run line 24. Nothing happens. So I would like this thing. What did we do in line 24? Can you read this for me? Sequence of numbers, good. Okay, so what does -3 mean? What does 3 mean? What does comma 0.1 mean? Perfect, let's find out. So how I'm gonna find out is I'm gonna go down to my console. I'm gonna type in X. And that looks exactly like what we got. We got -3, then -2.9, -2.8, all the way until we get 3 again. So we have a lower limit, we have an upper limit, and we're separating out by 0.1 each time. Perfect. One of the things getting to practice with R is just play. Try stuff. You know, so you define a variable X, find out what the variable actually shows you. What Misty told us was perfect. We run it, we actually get confirmation that she was correct. Cool. So then we do this. We run line 25. Notice I don't have to highlight everything. I don't have to be at the beginning. I don't have to be at the end. I just have to be within that sequence. What is the actual function being defined by? Where's the beginning and where's the end? The function is being defined by the first and the end parentheses. And there we go. Oh, good. Normal distribution. You create a bell curve. This is an idealized bell curve. How do you know it's an idealized bell curve? Because it's perfect. Absolutely magical. What we're going to do on Thursday is we're going to start here. On Thursday, we're going to start here. And then what we're going to do is we're going to simulate normal distributions. We're going to create random normal distributions with the same defined parameters for the very simple reason of seeing how random data can sometimes deviate from what we actually expect the data to be. These will all be normal distributions, but they will be generated randomly. Questions? Thoughts? Okay, have a great day. Oh, yeah, actually, last question for you guys. When do you want the next homework due? Descriptive statistics. I'm fine. When do you guys want it due? Now, if you don't have it due on Friday, it means we will not be able to give you feedback before you have your test. If it's due on Friday, then we will be able to give you feedback before your test. Your all's call. The test will be released sometime between Tuesday and Thursday, probably Thursday of next week after class is when the test will be released. Do it on Friday. Therefore, we will be able to grade over the weekend, so you guys have comments back. Okay? Have a lovely day. Give me 1/2 second.